So this is an example problem. It's number 18 from your textbook. You're driving down the road and your speedometer works, but your odometer doesn't work. Could you figure out how far you've driven down the road? So it turns out we can estimate this answer. We don't have a velocity curve, so we won't be able to draw in the whole velocity curve, but we do have enough information to find rectangles, and then we can use the rectangles to approximate the area under the curve. So just notice here, this is common. You would see a problem like this on the AP test. It's common to be asked to use a Riemann sum, a rectangle sum, when you don't have an actual function. All you have is a table of values. So just notice this table's written differently from what we're used to. We have the time down the side, and then the velocity to go with it. So instead of a table across like we usually see, this one happens to be written up and down. Just notice that the interval, the times that we care about the car going down the road from 0 seconds up to 120 seconds. That's 2 minutes. So we want the time interval. The time is the input variable, the input to the velocity function. We're going to break up that time interval, the 120 seconds, into little chunks. And each little chunk is going to be the width of a rectangle. And we're going to use the height of the function, the height of the velocity function, for the height of the rectangle. Well, remember, we don't actually have a velocity function, but we do have velocity values, and that's enough to tell us how high, how tall our rectangle is going to be. So, there we go. Things we need to double check. It says I want to use 10-second intervals, and we need to check the units. So time in this problem is measured in seconds. I can see that everywhere along here it's measured in seconds. And velocity, for this to work out, it's going to need to be in some units per second, so that when I multiply it by seconds, the seconds cancel. And you can see they even put a little note in here that they converted all of the velocities. So that's good. When you do problem 17 in your homework, you're going to have to do the conversion first. But for number 18, all the units are taken care of. So our first rectangle, this is the key. If you can do a rectangular approximation problem without actually drawing in the rectangles, that's the sign that you're on track. So think about that first rectangle. It has a distance across the bottom of 10 because it's going to cover from 0 to 10. How tall is the rectangle? Well, notice here we've been asked to use both LRAM and RRAM and then to average the two results. So I'm going to start by finding LRAM. That means I'm going to use the left-hand side of the interval, 0 to 10, and use the function value at the left-hand part of that. So when time is 0, that's the left-hand part of the interval, I want to know what the velocity value is. And we can see here, when time is 0, my velocity is 0. So I'm going to move this slide and show you the math I do. All right, so here's the addition problem I'm going to do. I have 120 seconds that I'm going to divide up into 10-second intervals. So it means I'm going to have 12 rectangles. And it turns out the way I've been asked to do this problem, each rectangle is going to have the same width, which is 10 seconds wide. And I'm going to multiply that 10 seconds by the height of the rectangle, which is the velocity value. And I want to take the velocity value from the left-hand side of the interval. So that's how I got this first 0. Because 0 is the velocity when time is 0. Alright, so now I'm going to add in the next rectangle, and that's going to be 10 wide times 44 feet per second high, plus the next rectangle, which is 10 seconds wide times 15 seconds high, 15 feet per second high. And I'm going to keep going here. So I'm going to finish adding up those 12 rectangles. They have a total sum of 3490. Now I'm going to find RRAM and I'll average the two. So I can write this second sum to add up the RRAM rectangles. And then in the problem I was asked to average the two estimates to get my answer, and I get the distance traveled is approximately 30